welcome you all back. Track number 2, that's always where we have very good talks. And after the lunch and shortly before the break, we have to have a little bit special ingredients, so we talk about surprising insights. The keynote this morning was about superhuman Gran Turismo, Sony gaming machine. Is this the stuff people learn in academia, in school? Is this the stuff you need if you own a business and you go to your production machine? Okay, where can I use now the superhuman Sony driver for this? So we talk a lot now about the discrepancies exactly in this kind of field. Welcome on stage, Thoralf Mildenberger, Kurt Stockinger, please.
Hello.
Thoralf is a lecturer in computational statistics at University Zurich of Applied Science in Winterthur. He has a PhD in statistics. Kurt is a professor of computer science, director of studies in data science at ZHAW, and co-head of the data lab. Kurt has been many times on stage, and I was told the professors love to talk themselves, so I shut up. Floor is yours.
Okay. Thank you. I keep it short. I will let Thoralf talk more. So. Good. So what do we talk about today? It's, as it was already introduced, the question is always, what is the big trends in data science? What is currently on vogue? And you know, everything is AI and you name it. And on the other hand, we are, as a University of Applied Science, we're also teaching. And we're teaching a data science program, and we've been doing this for quite a few years, and we wanted to see what is actually taught, and the third thing, what are actually our graduates doing afterwards. And here it's really like on the stage, I don't really see you, but I suppose some of our graduates are sitting in here, so you can even talk to them afterwards. So this is basically the picture that you say, you have on the one hand the hot topics in data science, on the one hand the techniques that you learned, on the other one the things that you actually apply. And you will see there's no intersection. This is the worst case, right? If we teach something which is irrelevant, we can close down. Okay, then maybe some other university can do it. This is the ideal case. Everything we teach is en vogue, and it's also used in industry. Maybe that's the other ideal case, and maybe there's something in between. So, and as was already introduced, there will be a little twist, so you will see what's actually going on. Maybe a little background, who we are. We are the ZHAW Data Lab, and this was founded in 2013. It almost sounds very Stone Age. 9 years ago, we founded this. At this time, we were pretty much the early movers. We were in Europe one of the first ones to actually do data science. Now, almost everyone is doing it. And we have an interdisciplinary lab. What is important, we founded actually this conference, maybe now it's even a company, in 2014. So we are not the godfathers, but the god sisters, and we are the family, so to speak. We have also published a book in our experience on data science, applied data science. If you haven't downloaded it yet, please do. Then we get all rich, because we get for every book you download, we get 0.00 Swiss francs. So this is how I can buy afterwards my lunch, okay, and give it to my kids. And then we also did a few other things. What is important, besides writing books and teaching, here's our data science program. And this is the MIS, Data Science Master of Advanced Studies in Data Science. And here we have 5 different Certificate of Advanced Studies, CIS. And you will see what is actually going in there. We have a statistics branch track, if you will, a computer science track, and in the statistics branch, you can read. So I'm sure you know, if you know all of these things, you can call yourself data scientists. If you have not used maybe 20%, you can still call yourself data scientist. And if you know less than 20%, you should attend our course, okay? So basically, we have these different things. I'm the computer scientist, and Thoralf is the data scientist, and he will give you an idea of what we actually did here, okay?
So thanks. As a statistician, we thought we should have a survey, so we conducted a survey among former participants of the program. And since the program has been running for quite a few years now, we had basically 1,300 people whom we wrote to, asking them to take the survey. Of course, not everybody did answer, but we had a response rate of about 10% or so, or even a bit higher, so 159 questionnaires were filled out, so this is okay for a survey, I think. So the survey contained several questions. I will show you not all of them today. So mostly were closed questions with fixed answers given, which people just had to tick. In many cases, one could pick more than one answer, and we usually also had some other category where people could also fill in what they meant by other, perhaps another industry sector or whatever. So we also had some open-ended questions, but these were also interesting to us, but I will not show them here. So first of all, the demographics of the participants. First of all, you see most of the participants are male, but quite a few female participants. Most are in the age bracket between 35 and 54. A few are older, and quite a few are younger. Then the background of the people. So since having a degree from at least the University of Applied Sciences, at least a bachelor, is technically a prerequisite of enrolling, most of these have one. So you have about 40% having a bachelor degree, 40% a bit more master's degree, and then about a bit more than 10% having even a PhD. And since it's possible, although it's strictly speaking a requirement, but as usual in Switzerland, we have these sur dossier enrollments where people can even enroll without the formal qualification if they did something more or less equivalent. So about 10% come to us without any previous academic degree. So which sectors do the people come from? You see, as is probably to be expected, most of the people come from IT, more than 20%. The next sectors are insurance and finance. You could take them together, then it would be even larger than IT. And then also government, research and education, including even one primary school teacher I've seen. MedTech, pharma, manufacturing, and other sectors are not as prominent like energy or transport and logistics. So, and this is basically what you see on the left-hand side. On the y-axis is more or less the same that you saw on Kurt's last slide with our CAS programs. These are all topics which are taught within our curriculum. So you have databases, visualization, R scripting, machine learning, and so on. And we asked the participants, of course, they all had, depending on which courses they took, they had at least a few of them in these courses. But a lot of people knew some of the subjects more or less, or were more or less familiar with the subjects beforehand. And we also asked them, and that is probably the most interesting part, what they actually use in practice now. So, and if you take a look, what is by far the top category here is databases in SQL. So this is definitely not a real hot topic, but it's something people knew about before, and more than 70% even still use this on a day-to-day basis. The same is true for visualization, scripting, data warehousing, and so on. These are all things which are both used very frequently now in practice, but also many people knew this beforehand. Statistics is a bit of an outlier. This is something many people knew beforehand, but didn't continue to use later on. I hope it's still because of doing so implicitly and not explicitly. And the same is true for other programming languages. And what is perhaps also of interest, all the hot topics like text analytics, deep learning, massive topic, prominently featured in our curriculum, lots of tutorials, lots of buzz about it, but not so often used in practice. So people did learn about this, but it's less than 20% of the data scientists graduating from our program who use this in their day-to-day practice. Also true for network analysis and advanced regression analysis. So what is taught or what is really hot is not necessarily what people use. A lot of the things which people really regularly use is kind of the very basic stuff, like databases. Okay. We also asked whether the format, these are questions about the format of the education, whether people could think they could have acquired the same skills in a more classical format, meaning either a statistics course or a computer science course or something like this. And most people said no, so this indicates that the mixture is about right. And also the other question was about if people would have preferred a broader education or more narrow but deeper education. And for most of the participants who answered, this was about right, with a few more saying they would have liked more focus and very few who said they would have liked more breadth. What do people do after the course if they still encounter gaps? Of course, we can't teach them everything. We can give them a sound education, but still, sooner or later, they will meet some problem they cannot tackle with the techniques we taught them. So, and we ask what would be the preferred approach to closing skill gaps after graduation. And here, the most popular method would be to do self-study with really available resources, followed by trying to achieve best partial results with what they do know. And what people generally do not favor so much is taking another course. So this indicates that one broad course is enough, and after that, they are well prepared to close the gaps on their own. Increased responsibilities after graduating. We ask people what they think would be areas where they would have more responsibility after graduating. And this, of course, includes analytics, which is kind of, really core of data science. But also often mentioned were product management, project management, product development, and to a lesser extent leadership. Personal and budgeting was not so much named here. Somewhat similar questions, which areas are the skills to be applied in? The top one was here, understanding of new technologies, not necessarily applying them, but tightly followed by building models, which would be also a core data science competency. Software development was also very popular, as well as establishing new business areas. Marketing and CRM or preparation for a new job are less often named here. We also asked about the job titles. We even had a third question on this. So it's a job title before or during the education and 1 year afterwards, meaning this could only be answered by people whose graduation was at least 1 year past. We also asked about the job title 3 years after the education, but we didn't get that many answers because many people are still too freshly finished. And what you see here, there are lots of different job titles: business analyst, BI specialist, data engineer, data scientist. These are probably of most interest. And you see here, after the education, the frequency of being called data scientist or data engineer increases, while most others slightly decrease. So the education seems to lead to people being called a data scientist. Okay, then I'll hand over to Kurt for the conclusions.
Good. So let's conclude. Let's digest a little bit what we heard now. In the morning, we heard about superhumans, and we play against computer games, and we use the latest, greatest deep learning stuff, reinforcement learning. And it turns out, at least in the Swiss business, it's not really heavily used. So it's more like database stuff. I'm a database researcher, so I'm happy that this is used. So these are really the nitty-gritty stuff, and so it's not the sexy stuff, even though database research is super cool because you can make things fast. But apparently, it's not what is on the radar screen. And maybe here you have to be careful. So keep it back, put it back on the radar screen. If you want to have impact, you need to work in this area. Python R, of course, programming is always important as a data scientist. Machine learning is picking up. But as I said, deep learning is in the news. It's all the big companies talk about it, and we now win all computer games against superhumans, whatever. The question is, why is it not there yet? Why is it not used in the Swiss industry? Very broadly, is the Swiss industry not ready yet Do we overtrain our data scientists? Do we overfit them? Do we have a bias in our training? Or are the pain points somewhere else? And my gut feeling is it's more the second one. I think it's good that you get all training. And the best thing is, why don't you combine the advantages of both? So assuming the data engineering is the hard part, getting the data right, cleaning it, integrating it, and we kind of all knew this story, right? 80% of the data is preparing. Now we have the facts. We have the facts from our survey of participants over the last 7 years, and these are the hard facts. This is what is currently the case in Switzerland. So why not using, and I remember in one of the first machine learning clinics that we had, this is also many, many years ago, I said already, why don't we combine machine learning stuff, which is cool and sexy, and deep learning with some boring data cleaning and data integration stuff, and actually solve a real problem. And you even had some problems with a big pharma company where we also worked in this data integration. And this is, I would recommend, this is a very interesting field. So for instance, recently we started to use transformers, so the latest trend in neural network architectures, for doing data integration, right? Data integration, you always have a data integration problem if you merge two companies, if you merge products from one and another one, where you merge customer information and so on. So data integration is a hard problem. And here we used transformers, and we were lucky that we were the first ones in this world to actually try it out. And it worked actually quite well. So here we used some benchmark data set, and what I'm kind of proud of, that the MIT guys said this many years ago, and then we tried it out, and we were a little bit faster than the MIT guys. So this was cool. Another thing is error detection in databases. And there are many, many errors in databases. I remember when I was once working in a Swiss bank, and I was working in the big data warehousing area, I could choose between bitemporal historization, which is kind of time machine, or data quality. I had no clue what data quality is. That didn't really sound interesting. But once you work with the data, you see there are many, many errors in there. So we also tried how we can use recurrent neural networks to detect errors in databases. And the problem is very different to what you actually do with traditional machine learning. Traditional machine learning is a typical big data problem, right? You need, especially if it's supervised, you need a lot of data and a lot of labels. In data integration or in error detection, you don't have many labels, right? And at some points you don't have labels at all. It could be an anomaly. How do we actually detect errors? So it's a small data problem, or let's say small. It's kind of also like an anomaly detection problem. And again, here we can use the fancy deep learning approaches and solve problems that are real pain points. So if you want to solve pain points and make maybe your clients happy, or your boss, you might want to work on these things. We're now working actually using exactly the approach that we tried here with error detection with a financial company from Zurich, and it turns out that all these approaches don't only work well on benchmark data sets, which is international use, but it also works on real data sets quite well. So this is the positive story. You can still use the cool stuff and solve some other issues here. Okay? So that's it for now, and open for questions.
Thank you very much, Thoralf and Kurt. So we have plenty of time for questions. If you all have questions, the hands are going up, so that's amazing. Here in front.
Keep this in the list. So, yeah.
So you said it's over 7 years. You didn't show how it develops, but I guess the numbers are a bit too small for that.
Yes.
How much can I trust that this is from the last couple of years? Because things have changed also in industry in these 7 years.
So the survey is recent. We did this in the end of 21. So people graduated earlier, but we did this actually the first time. So about what they do now, this should be pretty recent information. So it's not from 2014 or whatever.
What we could do, we could redo this survey every year and do the ZHW data science barometer and see maybe things change, maybe in a few years, and this actually could be interesting.
Could have a panel.
Does it pick up?
Yeah.
Yeah.
But then is the school fast enough to adapt to all this yearly survey? Can you adapt that fast to your programs?
I think currently we're a little bit ahead. Because we're doing already a deep learning which is not used. So
There was another question.
Yeah, Kurt, I wonder about the generalizability of your statement, because you cover only continuing education,
Yes.
and so you're not covering those who study at the university, do a PhD, and then go to work on a company. Probably many of those who do deep learning, they follow that path. So maybe these are underrepresented here.
yes, that's certainly true. It's a selection bias, and we selected basically our graduates, so the data scientists. Could be, actually that's a good point. Maybe deep learning is done by not data scientists, who are not educated as data scientists. This could also be. So one might want to redo it for all the companies and not check, but here it's really, we want to see what are our graduates doing that have the degree of a data scientist.
There's up one on the top.
To what degree is this survey available, public, or is it in your paper and otherwise closed?
What was the last part in your paper? What?
So I assume there's a publication to this presentation?
Yeah.
We are currently writing it.
Ah, very. I ask you to continue writing it, as I would really see kind of the full survey in that sense.
So
Because-
you want to have our questions, or you want the answers? Or
Both, ideally.
I think
No,
we
I
could
think
publish
it's
it at some
important
point.
that because we see that curriculas are not only evolving at ZHW, but at different places. And in that sense, we are, to some extent, at least on the education side, in a very similar domain. I mean, and therefore, it would be good that to promote the entire way of bringing this data science teaching. On the one hand, to remind some people that yes, you still need the basics. But you also have then, okay, teach the right things.
Exactly, yeah.
To your opinion, what do you think? So we have the technology, we have statistics, we have deep learning, we have data. Why? What's one of the reasons why is it not so often used in industry? You said, are there other pain points? Is it a cultural thing? On one side was leadership really at the bottom. Is it leadership? Is it a cultural thing? Is it the C-level? What you thought about that?
Let's say my experience from working in a large bank for some years where we did data integration and data warehousing, there's so many other things that need to be done first before you can do the same thing, cleaning. And in the end, when you have the data nicely structured, you can do machine learning. But all this preparation, especially in data organization, it takes a lot of time.
So the transformers we need to get the data wrangling done.
Exactly, to do the data wrangling faster, more efficient, less with humans. I think we cannot do it without humans, but I think, kind of active learning, human in the loop problems, using machine learning as long as we can, but we still need kind of some verification by humans. And that, I think then the job of data integration becomes more interesting. Maybe we even can call it data healing or whatever we can call it but this, I would say these are the real pain points.
One last question, please.
Thanks for the interesting presentation. A question about the survey again. Is there an effort in the educational ecosystem, so to speak, to combine data from different surveys, have a larger panel, different kinds of educational institutions, to get a fuller image? I think it's related to the question from the front earlier, where there's different Fachhochschulen.
Yes,
and
I think in the future we can do it. Here we were the early movers, since we have, as I said, we have our graduates over the last 8 years, and we wanted to have a first barometer, if you say, what's the snapshot, the current situation. But it's a good idea to extend it, and we can include more, and maybe do it the ZHW data science report, or not the Swiss data science report, and similar like the COV does the economic statistics, we can do the data science, what's going on. So I think that's a cool idea. I don't see you, so if you want to be involved, send me an email, and we can continue here in the future.
Thank you very much. I have the watch in my eye, so thank you, Toralf. Kurt, big applause to you guys.
Thank you.
Thank you very much.